This is also another example on resultant of forces, two forces acting at a point. We've looked at one example in the previous class, so let's look at this other example also. Calculate the resultant of two forces of 100 Newton and 80 Newton acting at 120 degrees to each other. Don't forget that to find resultant of two forces acting at a point, to find the resultant in magnitude first, you use R squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 180 minus theta. And to find the resultant in direction, you use tan alpha, alpha is equal to F1 sin theta over F2 plus F1 cos theta. This is the formula for calculating resultant in magnitude, and this is to calculate resultant in direction. So let's look at this example. Calculate resultant of two forces of 100 Newton and 80 Newton acting at 60 degrees to each other. So you have 100 Newton, 60 Newton acting at an angle of 120 degrees to each other. So this is the diagram. So you have F2 is 80 Newton. This is F1 is 100 Newton. You have F1 is equal to 100 Newton, F2 is equal to 80 Newton. If I complete this diagram as a parallelogram, I will have something like this. So the resultant of the two forces now will be the line that acts from the point of the action to this place. So this is the resultant in magnitude R, while the angle in this place now will be the resultant in direction alpha. So that's R and alpha, that's what we want. Then substituting it in this formula now, I will have R squared is equal to F1 squared, that's 100 squared, plus F2 squared, that's 80 squared, minus 2 times 100 times 80 cos 180 minus 120. I will have R squared is equal to 10,000 plus 6,400 minus 2 times 100 times 80. That gives me 16,000 cos 180 minus this is 60. So our R squared is equal to 10,000 plus 6,400. Now 16,400 minus 16,000 cos 60 is 0.5 into bracket 0.5 cos 60 is this. So you have R squared now is equal to this 0.5 times 16,000, that's minus 8,000. So you have R squared equal to minus 16,400. So that will give me 8,400. So my R will now be equal to square root of 8,400. So R that will give me 91.7 Newton. So their resultant in magnitude is 91.7 Newton. Then to find the resultant in direction, then I'm going to use this now. So let me clean this place so that I can do that here now. Then the resultant in direction using tan alpha now is equal to f1 sin theta over f2 plus f1 cos theta. That will give me tan alpha is equal to 100 sin 120 over 80 plus 100 cos 120. So you have tan alpha now will be equal to 100 sin 120. That give me 86.6 over 80 plus 100 cos 120. That's minus 50. So you have plus open bracket minus 50 here. So you have tan alpha is equal to 86.6 over 80 minus 50 plus and minus here. So you have tan alpha is equal to 86.6 everything over 30. Then tan alpha will be equal to 86.6 divided by 30. That will give me 2.887. My alpha itself will now be equal to tan inverse of 2.887. So you have alpha is equal to second function tan. That will give me 70.9 degrees. So the resultant in direction is 70.9 degrees, while the resultant in magnitude is 91.7 degrees. So this is another example of resultant of forces acting at a point. So you can check the solution, and if you have any question, you can drop it on our channel comment section. We'll make a video and drop it for you. Thank you.